This is part 2 of our lesson on exponent laws with negative exponents. We just looked at the rules for negative exponents, and we discovered that a negative exponent makes a fraction, and it also has a flipping over action. So we're going to try some actual questions to see this rule in action. So it says evaluate each of the following. Leave your answers in exact form, which means we don't want decimals here. So I have 4 to the power of negative 2. Now, a negative exponent makes a fraction. So it takes the base of 4 and it turns it into a fraction by flipping it over, and we end up with 1 over 4. And then the power stays the same except we change the sign, so it's going to be 1 over 4 to the power of 2 instead of 4 to the power of negative 2. Now, all I need to do to finish this off is square. So 1 squared is 1, and 4 squared is 16. So 4 to the negative 2 equals 1 over 16. Now if I try the next one, we have 10 to the power of negative 1. So a negative exponent makes a fraction. So it's going to take that base of 10 and turn it into a fraction 1 over 10. So this is going to become 1 over 10 to the power of positive 1. Now anything to the power of 1 is itself. So 1 to the 1 is 1. And 10 to the 1 is 10. So our final answer there is 1 over 10. Now the next one is already a fraction. We have 3 over 5 to the power of negative 2. So when it's already a fraction, it can't make it a fraction. So what it does is it does the flipping over action, and it flips it over. So 3 over 5 becomes the fraction 5 over 3. And then our exponent of negative 2 loses that negative sign and just becomes a positive 2. And then all we need to do is just square. So 5 squared is 25, and 3 squared is 9. So our final answer there is 25 over 9. So one more example here. We have 9 over 7 to the power of negative 4. So the first thing it's going to do, we have a negative exponent, so it's going to flip over that fraction to become 7 over 9. To the power of positive 4, and then we just evaluate 7 to the power of 4, and I think I'm going to use my calculator to help me with that. So 7 to the power of 4 is 2,401, and 9 to the power of 4 is 6,561. Now the next set of questions don't ask me to evaluate, they ask me to simplify. So when a question says evaluate, that tells me that I'm going to end up with a numerical answer. When it asks me to simplify, that tells me that there will likely still be variables in the question, which makes sense since we have x's, y's, z's, a's, b's, and c's in our questions. So it says simplify each of the following. Write your final answer with positive exponents. So I don't want to have any negative exponents in my answers here. So if I take a look at part A, I have 2x to the negative 3, y to the 4, z to the negative 5. So the ones that have positive exponents are fine. It's the one with the negative exponents that we're going to worry about here. Now I have a 2, an x to the negative 3, a y to the 4, and a z to the negative 5. One common mistake is that people think the 2x and the negative 3 go together, but really that negative 3 is just on the x. The 2 has its own exponent. It's actually a power of 1. We just don't normally write it in there. So I'm going to take all of the positive exponents, just leave their bases alone, and then the negative exponents, we're going to flip them over. So 2 to the power of 1, I'm just going to leave that as a 2. X to the negative 3, that negative exponent makes a fraction. So I take the base of x and I flip it over to get 1 over x to the power of 3. The y to the 4 is fine. It already has a positive exponent. And then the z to the negative 5 is going to flip and become 1 over z to the positive 5. Now, I'm going to evaluate the ones that I flipped. I'm going to leave the 2 alone. 1 to the power of 3 is 1, and x to the power of 3 is x to the power of 3. Y to the power of 4, we didn't do anything with that one. And then 1 over z to the 5 1 to the power of 1 is 1. Z to the power of 5 is Z to the power of 5. Now what I want to do is multiply all of these things together. And the way you multiply fractions is you multiply all the numerators together and all the denominators together. So it would help if I knew what the denominators were on 2 and y to the 4. If you don't see a denominator, the denominator is a secret hiding 1 there. So both of these have a secret denominator of 1. So I'm going to multiply all my numerators together. So 2 times 1 is 2, times y to the 4 is going to be 2y to the 4, times 1 is still just 2y to the power of 4. And in the denominator, 1 times x to the 3 is x to the 3, times 1 is still x to the 3, times z to the 5 gives me x to the 3, z to the 5. Now the question asked me to simplify, which I did, and to write it with positive exponents, and I don't have any negative exponents left, which means that is my final answer. Now, I want to take a look and see how I got from here to here. I noticed that the 2 and the y stayed in the numerator, but the x and the z flipped down into the denominator. So there is a shortcut here. If you have negative exponents and you have a bunch of terms together, the negative ones are going to flip down into the denominator, and the ones with the positive exponents are going to stay in the numerator. So when we try the next one, we're going to try to see if we can do it without doing all the middle steps. But if you find that too challenging, you're welcome to put the middle steps in if you like. So the next one here says 50, a to the 3, b to the negative 2, c to the 7, and d. First, I'm just going to fill in the missing exponents to help me out. This is secretly a d to the 1, and this is secretly a 50 to the 1. So what I want to do is leave all of the ones that have positive exponents in the numerator, and then take the ones with the negative exponents and flip them into the denominator. So the 50 has a positive exponent of 1. The a to the 3 also has a positive exponent. The b has a negative 2, the c has a negative 7, and the d has a positive 1. So in the numerator, the 50, the a, and the d are going to stay on top. And then because a negative exponent makes a fraction and it flips it over, it's going to take all of the ones that have a negative exponent and flip them down into the denominator. So that b to the negative 2 is going to flip down into the denominator to become b to the positive 2. And that c to the negative 7 is going to flip down to become a c to the positive 7. All right, the last one here, we have 10 to the negative 3, a to the 4, b to the 2, c to the negative 1, d to the negative 9. So first of all of the positive ones should stay in the numerator. The only positive one we have this time is the b squared. So the b squared is going to stay in the numerator. And then all the rest with negative exponents are going to flip down into the denominator. So that's the 10 to the negative 3, which becomes 10 to the positive 3. I missed the a to the 4, which is in the numerator. Sorry about that. C to the negative 1 is going to become c to the positive 1 in the denominator, and d to the negative 9 is going to be d to the positive 9 in the denominator. Now, I could stop here, but I usually like to evaluate any coefficients that I have that I can evaluate. So I'm going to leave the a to the 4 and the b to the 2 in the numerator. 10 to the power of 3 is 1,000. C, we have a choice here. You can write c to the 1, you can just write a c, it doesn't really matter. And then d to the power of 9. Now the next three are a little bit trickier. They have a little bit more complicated. They have an extra step here. So I have 3x to the 4 to the negative 2. So we said that a negative exponent makes a fraction. It has a flipping over action. But my general rule is that I don't flip unless I don't have any other exponent rules to do. So here when I have a bracket and I have a nested exponent, I will do the exponent law for that first and then take a look at any of the negative answers I might have at the end. So the very last thing that I will do in the question is flip. So here, when we have brackets with an exponent on the outside, the rule that we have for that is we multiply. And I'm just going to zoom in a little bit here. So if I have 3x to the 4 to the negative 2, what I'm going to do is multiply that negative 2 into my exponents. And it multiplies into the exponent on the x, but it also multiplies into the secret exponent on the 3. And this is going to give me 3 to the power of negative 2 times x to the power of 4 times negative 2 is negative 8. Now, those negative exponents, they flip. And we talked in the previous examples about how anything with a positive exponent stays on top, and anything with a negative exponent is going to flip down into the denominator. So the 3 to the negative 2 is going to end up in the denominator, and the x to the negative 8 is going to end up in the denominator. So what stays in the numerator? Well, if there isn't anything else there, there's a 1. Now I am going to evaluate that 3 to the power of 2, which is 9, x to the power of 8. So the trick for these questions is when you actually have some exponent rules, multiplication, division, or a bracket, you need to work those out first, simplify as much as you can, and then at the very end, do the flipping. So if I take a look at the next example, we have 5a to the 4, b to the negative 2, c to the negative 3, all to the power of negative 3. So the first thing I notice is that I do have brackets with an exponent on the outside. So I am going to simplify that as much as I can first. So I'm going to multiply negative 3 by negative 3, negative 2, 4, and that secret exponent on the 5. So I'm going to end up with 5 to the power of 1 times negative 3, which is negative 3, a to the 4 times negative 3, which is negative 12, b to the negative 2 times negative 3, which is positive 6, and c to the negative 3 times negative 3, which is positive 9. Now, I've run out of exponent rules to follow, so I'm just going to flip anything that happens to have the negative. I'm going to leave the positive, so the b to the 6 and the c to the 9 in the numerator. And then all of the ones with the negative exponents are going to flip down into the denominator. So 5 to the 3 and a to the 12. And then my one last step, I will evaluate 5 to the 3 since I can. So I'm going to leave b to the 6, c to the 9. 5 to the power of 3 is 125, a to the 12. Now our last question, I have 2x to the negative 5, y to the 7, all to the power of negative 8. So I see that I have brackets with an exponent, so before I do anything else, I'm going to simplify by multiplying that negative 8 into all of my exponents, the 7, the negative 5, and the secret 1 on the 2. So 2 to the power of negative 8. X to the power of negative 5 times negative 8 is 40. And y to the power of negative 56. So anything with a negative exponent, I'm going to flip. Anything with a positive exponent, we will leave. So the x to the 40 is going to stay in the numerator. And the 2 to the negative 8 is going to flip down into the denominator. And the y to the negative 56 is going to flip down into the denominator as well. And then my last step is to evaluate the 2 to the power of 8. So I have x to the 40 divided by 256, y to the 56.